Alright, let's take a look at this. What we're going to do for today's lab. Using buses. Right, so the bus is the bundle of wires, right? Since we are expecting more than 1 bit, it's actually 8-bit digital modules. So first of all, we build this inverter. We have done this for several times, and then you can create an array of it. Okay, and this is a circuit we're going to cover at a later time of the semester. So if you have all the inverters being shorted like a ring, so the final output is shorted to the original input to form a ring, and it's going to start oscillating. The reason for that is the propagation time delay for each stage, and we'll eventually do the calculations to see how much the time delay can cause the frequency of the oscillator. But eventually now we just need to know that if you short them like a ring, it's going to oscillate. Okay, that's something we need to know. And you can imagine if we only have, I think we have 11 over here. So what if there are like 110 or even more? So in that case, it's probably not really doable if you just manually draw the schematic out of it. So there's a way to do that, which is using a bus, right? It's called a bus, a bundle of wires, something like this. So the way to do that is just draw one symbol, and there's a bus component from the library, and you click it, and you left click here and right click to introduce it, and then you add a port to it and then name it. So the thing is, how can I figure out the name of each wire in the bus, right? So the way to do that is you name it in a certain sequence. So I drew a diagram to make it easier to understand. Take a look at this one. So for example, this guy over here on the top with the bus, 2 buses, input and output, is actually equivalent to this schematic. So this is 11 components from 0 to 10, right? So if you want to create the bus for this component, you have to name it as something and bracket 0 to 10. So it shows that there are 10 devices over there being overlapped. And this is just my manual drawing in MS Visio, the drawing tool. So you can see these are all the 11 inverters, right? This is equivalent to this guy over here. And for the inputs, you can see that's a bus, but that's equivalent to 11 wires. Over here, 11 inputs, right? And these are the 11 outputs. So when you name it, the sequence here matters a lot. So for example, you name this port, the input bus, as oscillation output, right? OSC underscore output and comma, and then out 0 to 9, out 0 to 9. That's just all the names of the inputs, because the first one is oscillation output, and all the rest, the names of them are out, because I want to short these ones to the output over here accordingly for each of them. So you can see this guy is shorted to 0, out 0. Okay, and this one is shorted to out 1. Okay, so by doing that, it's actually shorting here, shorting this one to, you can see this guy. If you draw a physical wire, this wire is actually wired to this one, okay, and this to this one, and the first one here to the third one here, okay, and eventually this one is shorted back to the input. The output of the final one is shorted to the input of the first one. So this is creating a equivalent ring as what we just show you here above this figure. Okay, it's going to be the equivalent schematic. So the way to make the connections is just giving them the same names. If you want to short these wires up, you just give them the same names. That's it. So you can see the benefit is that if you have a lot of equivalent devices and you want to short them in a certain way, you just draw one and draw a bus and name them accordingly. Make sense? And you can see all the rest of the tutorial shows you how to. So first of all, after you do the schematic of this device with the buses and array, you have to create the layout. So the question is, can you create a layout using bus and array? Can you do that? So schematic, you can just draw one, right? Just draw one, and then draw a bus. What about layout? Why not? Right? Should we do that for layouts? So what are layouts? What these really are?
How that will be laid out on a
Yeah, layouts are actually physical circuits, right? Schematics are symbols, but layouts are physical circuits. So don't really want to create a bus and just the one symbol to represent everything. It's just it should be a physical circuit, right? So schematic is fine because these are just symbols. So for layout, you have to, if you have 11, you have to create 11 physical ones and make certain connections, right? So now I already finished the first one, layout, for one of them, and now I have I created a ring oscillator, which is the name of the 11 inverters in that schematic. So I started I drag this individual one's layout, I drag it and drop over here. Okay. If I don't click that little eye tool, it wouldn't show the details of the layout. Okay. But I'll only give you the ports. The ports are available. You can make the connections for the ports. So I drag one, and then I believe you are allowed to create an array like this, right? Go to array and align them in a row, okay, and then make certain connections for BDDs and inputs to outputs and also grounds. And if you want to pass NCC, you have to export the middle ports from L0 to L9, and also this guy, because your schematic, it does have these ports, right? So you have to name the ports in the middle. So the thing is, you have the input output, you make the connection, and it's from the wire, right? And the name of the port will disappear after you make the connection. So you have to pick up one of the nodes in the middle over here. It doesn't have to be, it could be either one, or you can just add a little metal node in the middle and overlay, put an overlay on the top. But you know, you just have to create the port, export it, all the middle wires to pass NCC. Task 2 will be a different schematic. It's an 8-bit AND gate. So you can see it's a very similar strategy. You create a one AND gate, and then you introduce the buses to the inputs and outputs, and you are not forming a array. So these are all in parallel. Right? Just 8 bits of AND gates. It's 8 bits, bitwise AND logic for 8 bits of binary numbers. So to do that, so first you need definitely the bus, right? The bus is over there, and then these are the nodes. Keep in mind, I have to use this guy, and you put 8 of them over here, and then you just make the connection. Okay, it doesn't matter. Just make the connection, and then the result looks like this. Right? Just the one bus. If you don't introduce individual wires, it's just like one bus. Okay? But you do have these individual nodes in there, and to differentiate between these different wires, you introduce a single wire from it, and just the left and right click, introduce a single wire for each node, and name them with one of the names of the bus, of the wires in the bus. Okay? So in that case, these will be different wires from the bus. Even though it looks like it's just one bus, it's already in the bus, but actually you can introduce each wire, 8 wires, and name them in different names to differentiate between all the wires in the bus. And make sure that these are control I. These are arcs, not exports. Okay, keep in mind, I saw a lot of issues from last year because they directly export it. Actually, these are control I and arcs, and then rename it. So in that case, you can get rid of. Also, while we are doing this, because there are inputs, we put a junction. So this junction component will merge all the A bits. That's just a way to simulate the AND gate, because you you have basically have 8 bits to AND with another 8 bits over here. So A and B, right? So both are 8 bits. And even to run a simulation, it takes, I don't know how many combinations. It's a lot of numbers to try to verify this logic of the AND gate. So we don't really have to explore all these logic inputs. So one way to do that is I just directly merged all the buses for the A input. Put a junction component over here, so it's gonna merge all the wires in the bus, and then I short everything to VD. So I'm basically giving 1 to all the A's, giving 1 to all the A's. So if I do an AND logic, I should really see the B's at the output, because 1 and anything is still that thing, right? It's not changing that logic. And for B, I'm doing 1, 3, 5, 7 for VDD, and all the rest are zeros, right? So if you do the AND logic, you can expect there will be, so the output is gonna duplicate the B, right? So it's gonna be 0, 1, 0, 1 like that. So you can verify it by one logic input, and you can change the logic input and verify it one more time, right? So you can see the first one I gave all 1s to the A input, and B's are like 0 and 1s, and for this one I changed it a little bit. So one thing, if you haven't seen this before, the simulation, you can see it won't be exactly 0, right? So you are probably seeing something nanovolts, and you are saying this is not 0. It's actually 0, right? It's just the LT spice is giving you that little tiny voltage leakage. So if you see a 4.99 something, it's actually 5 volts. If you see a something nanovolts, it's actually 0 volts. Okay. Run a couple of simulations, and then do an AND gate layout. Very similar way of doing the ring oscillator layouts, right? So the AND gate, and then NOR gates, same thing. Okay, especially repeating the same technique. But one thing you need to know that, so all these gates are going to be used for the final 2-week lab over here. Yeah, it's mid-October, right? It's going to be used for this lab. So you want to plan ahead of time. So the thing is, for this guy, you probably want all of them at the same height. You can see, I mean, the better way to do it is actually have everything at the same height. You know, some of them are not, but at least for the 8 bits, these are exactly in the same height. Yeah, just keep that in mind, all right? Other than that, I don't think there's anything else I need to talk about. It's very straightforward. Gonna start working on it. Any questions? No? Okay.